So students, continuing with the interesting effects of light which is getting which passes through the Earth's atmosphere to create beautiful occurrences. We continuing with that discussion of this particular chapter, and we are going to a new section where we deal with the scattering of light and what's called a Tyndall effect. Now, if you are dealing with a true solution basically means a solution. A solution obviously consists of a solute and a solvent. And what if the solute molecules as well as the solvent molecules are quite of the same size, are very tiny, of the same size? Something like you have a solution where the solvent as well as the solute molecules are something like very fine and very small, something like approximately something like 1 nanometer, that is 10 raised to minus 9 meters, so something like that. So obviously it's a homogeneous mixture. For example, sugar which is dissolved in water can be considered something like a true solution. So in such a solution, if a beam of light is passed through it, you will not be able to see it because the light is not getting scattered by the particles inside the solution. Now, if the size of the particles is larger than that, naturally we are dealing with particles which are suspended in the solution, which is called a colloidal solution. Naturally, the path of the light beam will be visible. Now, which obviously means when compared to the true solution, here we are dealing with a heterogeneous, means a difference in size of the particles. That is, the solvent particles are very minute, but the solute particles are larger. That's the meaning of it. So a very common heterogeneous mixture is something which we all are experiencing day to day, is the Earth's atmosphere. It's a heterogeneous mixture, and it consists of particles of different sizes. You have the smoke particles, we have tiny water droplets, so there could be other suspended particles, dust could be there. Obviously, you have the air molecules. So all these different types of particles are there, of different sizes, some bigger, some smaller. Obviously, it's not a homogeneous, it's a heterogeneous mixture. And suppose these particles are quite fine in size and you're passing light through it, naturally it will get reflected in a diffuse manner and you'll be able to see the light beam. I mean, when the light is passed through the atmosphere, where the suspended particles are quite fine, you'll be able to see the light beam. And we can think about very common two common examples. One is that if a dark room is filled with smoke, and sunlight is passing into the room through a small hole, you'll be able to see the beam of light. A very common example, if you walk through forest areas, is especially in the morning where there's a lot of mist in the air, you'll be seeing something like the sunlight getting scattered through the leaves. I mean, something like sunlight is something like getting scattered, getting split through the leaf canopy, something, and that is caused by the water droplets, that is a mist, the water droplets in the mist. So these two examples is a very good example of what is called the Tyndall effect. Now, what is the Tyndall effect? It is the phenomenon of scattering of light by colloidal particles. Now, understand that colloidal particles should be of a particular minimum size for this thing to happen. If it's a very fine size, and if we are dealing with a homogeneous solution, such a effect won't be visible. Now, so you can see that in the case of the smoke-filled room, and also in the case of the mist which is hanging in the forest, it's the scattering of the light makes the particles which is causing this thing to become visible. Now, a related topic, what about the color of the scattered sunlight? Now, once again, it's the same principle. Obviously, it depends on the size of the scattering particles, and if so, you can consider three types of particles over here. So if we are dealing with very fine particles, naturally the scattering will be mainly towards the blue section of the spectrum. Now we know that the white light, sunlight has with geo, that is 7 colors, and it will be mainly towards the blue light, and which means that the shorter wavelength, the part of the light which has, the part of the spectrum which has shorter wavelength. But if the particles of in the atmosphere is something like an average, a little more than average, a larger size, it will be more towards the yellow orange, towards the reddish part of the light, which means that we'll be dealing with longer wavelengths. And what if quite large particles in the atmosphere? Naturally, there may not be any scattering as such. You may even be something like just reflecting something like the white light. So that's about this particular section. Next section we'll be looking at why the sky is blue. Thank you.